Hi, welcome back to the video for 4.1 and 4.2 exit ticket. So in this video we're going over both 13 and 14 because they sort of follow one another. So we're going to begin with problem 13. In problem 13 it asks you to write the balanced chemical equation for the reaction of two ionic compounds. So problem 13 uses different ionic compounds. I'm going to use lead, 2 nitrate, and lithium bromide, but it's the same process. So these are not the same problems in your exit ticket, but by looking at this, you can sort of see how to do it. So we're mixing two ionic compounds, lead nitrate and lithium bromide, and we know that if we do that, we're going to get some double displacement reaction. Remember, which sort of follows this format. So for double displacement, they change partners. First and last, so that's AD, and then the inner ones, and that would be CB, okay? So that's what we're looking to do here. But in order to get to this point, I need to know what the chemical formulas are. And this is what you learned in the last unit. So if this is something that is difficult for you, you want to review the stuff from last unit to sort of help you, or come to support hours. That's what they're for. Okay. So lead is a transition metal, and I know that I can just tell that just from the name because I have in parentheses Roman numerals, which tells me the charge on lead. So if I look in the periodic table, the symbol for lead is Pb. And since it's in parentheses, I have a Roman numeral 2, that means the charge here is +2. Now, if it's not a transition metal, you would have to, if it's not a transition metal, there will not be the charge in Roman numerals, so you would have to figure out where it is in the periodic table. But in this case, that's the charge based on that value in Roman numerals. Now nitrate. Nitrate is a polyatomic ion. So for that, I'm going to go to my handy dandy chart here. Nitrate, here we go, has a -1 charge. All right, so in order to write the chemical formula for this, remember we want to have the overall charges to be 0. So I need to have the right number of leads and nitrates in order for the overall charge to be 0. So in this case, this has a +2 charge and it has a -1 charge. If I add them together, that's not 0 yet. I would need 2 nitrates in order to get the overall charge to be 0. So the chemical formula here will be PbNO3, 2. All right, let's go ahead and look at it for lithium bromide. So lithium, notice that there's no number in Roman numerals next to it, so that's my clue that this is probably something I have to look in the periodic table. So lithium has a, if you look in the periodic table, it's in group 1, the symbol is Li. If it's in group 1, the charge is +1, okay? So group 1 has a +1 charge. And when I say group 1, what am I talking about? For those of you who forget, the columns in the periodic table are numbered. This will be group 1, this is group 2, this is group 13 because we're skipping the transition metals here, 14, 15, blah, 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 all the way up to group 18. And group 1s have a +1 charge. Oops, let me do that again. I always forget where my view is. So this is our periodic table. This is group 1, this is group 2. We skip the transition metals, 13, 14, all the way up to group 18. Group 1 has a +1 charge, so this one has a +1 charge. Now bromide, Br, if you look in the periodic table, it's in group 17, which is right here. Okay, this second to last or penultimate group. That group has a -1 charge, so bromine has a -1 charge. Okay, so the chemical formula for that, I just need one of each in order for the overall charge to be 0. It's +1 and -1 gives me 0, so LiBr. Okay, cool. So now what I need to do, now that I have my chemical formulas, now I can go ahead and switcheroo them and get my products. So move that over first and last. So the lead goes with the bromide, and then the lithium will go with the nitrate. So my first product I'm going to write here is PbBr. All right, now I combine those together, but I need to make sure this formula is right. And for that, I need to go once again and look at the charges. Lead has a +2 charge. Bromide has a -1 charge. In order for this ionic compound to be neutral, I need 2 bromines. All right, so now for the next one, lithium nitrate. Lithium has a +1 charge. Nitrate has a -1 charge. Then they get together, LiNO3. Just need one of each. Okay, cool. All right, now that we have that, we can go ahead and balance them. We have our chemical equation, but it's not balanced. Well, we need to check to see if it's balanced. So to do that, for ionic compounds, remember, you want to treat the, you want to list, instead of the individual atoms, list the cations and anions. It's so much easier. You could do the individual atoms if you wanted to, but it's going to take you forever. So, all right, so Pb is lead, so there you go. Nitrate is that's our anion, polyatomic anion. That stays together, just treat it as a group. Lithium and bromine. All right, do the same thing on the other side, so Pb. And what I'm going to do is I'm just going to copy what I have on this side. I like to keep them lined up just because it makes it easier for me to check, but you don't have to. Okay, so now let's count how many of each we have on both sides. So lead, I have 1 lead. I know that because there's no subscript next to lead. I have 2 nitrates. I know that because nitrate is a polyatomic, so if you have more than one, it would be in parentheses, and the number outside the parentheses tell you how many you have. So here I have 2. So just want to let you know that for polyatomics, ignore the subscripts within the polyatomic. You have to look outside the parentheses to figure out how many of them you have. Lithium, I have 1. Bromine, I have 1. Over here, 1 lead. Bromine, I have 2. So put that over there. Lithium, I have 1. Nitrate, I have 1. So looking at this, I see this is not yet balanced. I have my leads are good, my lithiums are good, but my nitrates and my bromides are not good. So what do I need to do? Let's go ahead and balance them. Let's start with the nitrates. I have 2 on this side and 1 on that side. So what I want to do is I want to change the coefficient in front of lithium nitrate to 2 in order for me to get 2 nitrates on both sides. Now remember, the way that works is I had 1 nitrate here and I had 2 on the reactant side. So I'm going to go to the side with the least amount of nitrate, and I'm going to ask myself, well, what times 1 will give me 2, because I want the 2 numbers to be the same, and that will be 2. So I have to double the number of nitrates. All right, the bromines or bromides, I have 1 on the reactant side and 2 on the product side. So once again, I'm going to go to the side that has the least amount, find the molecule that has bromide in it, which is lithium bromide. I want 2 of those, so I'm going to change that to 2. Okay. Now when I do that, when I change the number of lithium bromides, I also change the number of lithiums as well. So there should be 2 lithiums here. And I forgot to do that over on the lithium nitrate. When I change the number of nitrates to 2 by putting that coefficient in front, I also change the number of lithiums to 2, since this molecule has both lithium and nitrate in it. All right, so now I look at this. This is a balanced chemical equation. Okay, so that part is done. So just to recap, you have your name. From the name, you have to write the chemical formulas of the reactants that they give you. So lead nitrate, this is the chemical formula. Lithium bromide, that's the chemical formula. Then you switch the partners to make your products. And once again, you want to be careful of the chemical formula, making sure that the overall charge is neutral or 0. Finally, to balance, you tally the cations and anions, so you break them apart into their cations and anions, and then you change the coefficients so that you have both sides have the same number of cations and anions. All right, that's question 13. So for question 14, it asks, well, which one of these is a precipitate? And so for that, you need to go to this chart now, your solubility chart. So what we're going to do is we're going to look at lead bromide and lithium nitrate and see if we see a solid. So if we see S for solid, then we know it's a precipitate, because that means it doesn't dissolve, so it stays as a solid in solution. Okay, so starting with lead bromide. So I go in this table here, I look for lead. Okay, all right, so lead is here, lead 2 is here, and I look for bromide. There we go. It's that first one there, that's an S, so that tells me it's a solid. So that means, I'm going to put that S there, this is my precipitate. Okay. Now let's just check to see if lithium nitrate is also precipitate, because sometimes you can have 2 things that are precipitates. So lithium, look for nitrate over here. Lithium nitrate, I see AQ. Well, that means that it's soluble. So AQ means it's soluble, that means it's not a precipitate. So for question 14, if this was question 14, I would say PB R2 is a precipitate, and PPT is just an abbreviation for precipitate because it's solid. All right, so that is it for question 13 and 14. So for the last video I'm going to do is on question 15, the acid-base neutralization reaction.